Cheers, everyone. Today we will explore loops in Python, which is a fundamental tool for automating repetitive tasks in programming. So let's get started. In this lesson, we will learn a few stuffs. So the first one is to understand what is a Python loop. And then the second learning outcome is to learn how to construct loop statements. And then we will learn how to apply loops to solve mathematical problems efficiently. So now, what is a Python loop? So a Python loop is a programming structure that repeats a set of instructions until a condition is met. So usually the programmers use loops to process multiple values, compute repeated calculations, and automate repetitive tasks. Well, loops makes programs more efficient by reducing redundancy in the code. This is particularly useful if you have many lines of code that repeat themselves. So now let us imagine if we want to compute a sum using the formula, which is the summation of the inverse of the square series. So we have many terms over here. So the first term will be 1, and then the second term will be 4, 9, 16, 25, and so on, until we reach to the point where the denominator here is 1000 to the power of 2. So first we initialize a variable sum equals to 0 because we want to accumulate the sum. So we must begin with 0. So and then the next line will be sum equals to sum plus 1 to the power of minus 2, because this for each term over here it is the inverse of the squared. So that's why we have to the power of minus 2 over here. So initially we begin with 0 for the sum. So here the sum will be updated with the previous value of the sum, which is 0, and we add with the first term. Then we keep on repeating the same procedure for 1,000 times, because we have to do the summation for 1,000 times. Well, writing 1,000 lines of code manually is a bit inefficient, even though the job is accomplished. So this may not be a smart algorithm, but at least it will get the job done. We can use loop to simplify these 1,000 lines of code. For example, here, if you see, I have my 1,000 lines of code, and then I can compress them into a single line by just using Python loops. In Python programming, we have two different types of loops. So the first one is the while loop, which repeat a block of code while a condition is true. Then the second one, we have the for loop, which will iterate over a sequence, such as a list or range of numbers. So for each loop type serves the different use cases. So we will explore that in the next lesson. So now let us focus on the for loops. So again, for loops repeat one or more lines of code according to a sequence, which can be a list of numbers or in general Python objects. Well, of course, we will dive into the details of Python list in the next upcoming lesson. But before that, I will introduce you to for loops. Instead of repeating the code manually, we can use a for loop to solve the earlier summation problems. Well, let's dissect into this for loop structure. Well, a for loop requires the for and the in keywords. So the for and the in keywords. For example, we have here for and in some list of numbers. So here, this part is a list of numbers. So this line is the control expressions that helps to identify the behavior of the loops, such as how many repetitions or when to stop. And then again, remember to include the colon character here, over here, which is similar to the if-else statement, like what we've learned before. The range function here defines the sequence of numbers in the loop. For example, here, this is a list of integers that starts from 1 and then ends at 1000. So here, even though we type in 1001, well, it is not included in the list. So it ends at 1000. But then it is spaced at an interval of 1. So this flexibility offered by Python allows the precise control over iterations. So it is common for Python programmers use the range function. If we dissect this loop further, here we define n as the variable. You can always change this into another names, but for this purpose, I'm using n. It is the object, okay, which is an integer for this particular case. And this is the object selected from the list of integers specified by the range over here, range 1, 1001, and then 1. Basically, this is a list of integers from 1 to 1000, as I explained earlier. So now n will be the element of 1, 2, 3, 4 until 1000. So if we were to write this in mathematical terms. So now the contents of the execution, because the loop will execute repetitively. So the execution block is specified in the red box over here. So all you need to do is to remember to indent your loop block. And this is the loop block where one or more lines of code to be repeated. So it is not limited to one line. You can always put as many lines as you want it to. But as long as you put the indentation over here, which is important to specify which part is the body of the iteration or the body of the loop. Since I have introduced to you the range function before, so it is important for us to discuss the details on the usage. So for instance, here we have the range function. So the first parameter of the function is the start value. And the second one is the stop value. And the third one is the step interval. So for example, if we put range 1, 1001 with the step 1, it means that our sequence of numbers begin with 1, and then it proceeds with 2, 3, 4, and so on until 1000. So but here, even though we specify that we should stop at 1001, but basically it is not included in the list, right? So this is the step interval. So for example, if I change this into 2, then I'll change the sequence behavior. So maybe it becomes 1, 2, 3, 5, 7, and so on. But still, it will not include 1001. I have a few other examples over here. So for instance, this is range 5, 10, 1, which means it begins with 5 and then it ends at 9, because 10 is not included in the list. Right. So we have, for the second example, we have 5, 10, 2. Again, it is the interval of 2. So it begins with 5, 6, 7, 9. And then it will not continue because we want to stop it when it reaches 10. So 10 is not included in the number, in the list of numbers. And then we have another one, 1, 10, 5. Again, this is something that you can think of. But I would like to focus on the last example, which is a bit interesting because the interval is -1. So it means that the sequence is decreasing, which is in the reverse direction. So we begin with 10, and then we reduce by 1, which is 9, 8, 7, 6. But it should stop at 5, and 5 is not included in the list. We move on to the while loop. Again, a while loop keeps on running as long as the condition is true. So unlike the for loops, while loop don't rely on the predefined sequence, but continue running until the condition changes. So this is important. The while loop depends on the conditions. So for for loop, it depends on the list that you want to iterate. But again, this is how we evaluate the summation by using the while loop instead of using for loop. Now let us dissect into the structure of the while loop, which is relevant for the summation problem. So here, a while loop requires the while keyword. So we put the while keyword over here. And again, this is the variable where we want to store the iteration value. For instance, we want n equals 1 for the first term, and then n becomes 2 for the second term, becomes 3 for the third term, and so on. So remember to put the colon character over here. This is something similar to the for loop. So I believe you can always remember this. Now, unlike in the for loops where we have to provide the list of numbers by using the range functions, now we don't need the range function, but instead we need to supply a stopping conditions, which also acts as the loop's conditional expression. Well, the loop will always continue whenever the conditional expression evaluates to true. For instance, we have the conditional expression here. So it will always repeat as long as n is less than or equals to 1000. So as long as the condition here is true, then it will keep on repeating. Well, the while loop doesn't know anything about the sequence. Then we need to update the value of n here. Over here, this is the n. We have to update the value of n after the execution of one loop task. So for instance, over here, we initialize n with 1, and then we go through the loop. So while n is less than or equals to 1000, which is correct for the current conditions. And then we will evaluate the expressions over here. And then next we will update the value of n. So now since n is 1, and then we update it with 1 plus 1, so now n becomes 2. And then it will repeat again and again, and the condition will check whether n is still less than or equals to 1000. But I have to tell you something, that if it is not updated, I mean, if the value of n is not updated, then the loop will run forever. This is something that you have to avoid. This is something that will cause your program to be not responding. Well, based on my judgment, I would say the for loop seems to be more useful in this particular summation series, because we know that the term stops at 1000. So a while loop is more useful in the case involving infinite evaluation, in which its termination is based on a stopping criteria. So in this situation, let's say if we change the summation series into an infinite series where we don't know when to stop, in this situation, the stopping criteria here is when the terms becomes very, very small, up to 0.000000001, so which is very, very small. Then we need to have that condition so that the loop will stop. So in this sense, a while loop is more suitable. So I have a challenge for you. Use while loop for this example. Let's see how. Well, this is something similar to the previous if-else statements in the previous lesson about the nested if-else. So loops can also be nested inside the other loop. So for instance, in this figure here, you will see that this is one loop, second loop, and then the third loop. So each loop will iterate over its own sequence, creating multiple levels of repetition. Sometimes we need to control and alter a loop's execution. So here we have the break keyword and also the continue keyword. So the break keyword stops the loop immediately, right? And the continue keyword will skip the current iteration and move to the next one. Now, let's take a look at how the break statement works in this particular nested loop. So we have three nested loops iterating through the values of x, y, and z over here. And then each loop runs from 1 to 99 because we're using the range functions with 1, 100, and 1, and 100 is excluded here. So inside the innermost loop, we perform these calculations. So this line, and this line. The thing is, we put the break keyword over here. So the break statement immediately exits the innermost loop where it is placed. Since it is over here, then the line here and this one will not be executed. So it will immediately jump to this point where it prints break the exit line, and then it will continue for the next iteration of the while loop. So what happens in the execution? So the loop starts with x equals to 1, y equals to 1, and z equals to 1. And then the break statement stops the z loop immediately, right? So the line here is executed, but not this one and this one. So that is the idea. Now, let's explore how the continuous statement affects this nested loop. So we have three different nested loops altogether for x, y, and z. So each running from 1 until 99, because here we have used the range function starting from 1 and we end at 100 with this step interval of 1. So inside the innermost loop, which is the loop for the z variable, we perform these calculations, summation equals to summation plus x to the power of 2. This means that we are updating the value of the sum. So how continue works here? So the continue statement skips the remaining lines of the code inside the current loop iteration. So here, for example, it will skip this particular line of code, but instead it will return back to here. So this means that Python immediately jumps to the next z iteration without running the skip line. So I would say the gray line here is the skip lines. So this is the idea of using the continue keyword. So that concludes our lesson on Python loops. Congratulations. So we've covered how to use loops effectively, and then when to choose the for versus the while loops, and then how to control them using the break and continue keywords. But before we end, let's list a few important key points. Point number one is that the loops automate repetitive tasks by reducing manual coding. And then the next one is that the for loop iterate over sequences, while the while loops run until the condition is met. And then finally, the break stops the loop, and then while the continue keyword skips an iteration. So I think that's all for now, and then I'll see you in the next lesson. Bye bye.